Hello chemistry class, it's Mr. Ng, and in this short lesson I wanted to show you how to do your titration problems. So here we have a sample problem that's not unlike the stuff that we've been doing in our actual titration. And if you recall, the way we did this math is we set up a table with our titrants, the stuff that we know, versus our unknown, right? This is the stuff that we don't know. And we listed the molarity, the moles, and then the volume. So let's fill out this table. A student titrates 40 mils of an HCl solution of unknown concentration. So it looks like this is the volume of the unknown. So I'm going to write that here. Instead of writing 40 mils, I'm going to convert that to liters real quick. So that's going to be 0.04000 liters, right? With a 0.55 molar NaOH solution. So that seems to be the molarity of our titrant. So that's 0.5500 molar. And the volume of the base needed to reach equilibrium is 24.64 mils. And again, I'm going to just do some mental math and convert that into liters. So that becomes 0.02464 liters. If you're wondering how I did that, I just divided it by 1,000. Great. Now that we are here, the first thing we could do is figure out the moles. And then that's going to figure out the moles of our unknown. And then that'll get us to the molarity, which is what the problem wants. It wants the concentration. So part one, let's find the moles of the titrant. And we know that molarity is equal to moles over liters, right? So let's plug in where big M is going to be 0.55 molar is equal to, we don't know our moles, so that's going to be our X, divided by our liters, which is going to be 0.02464. So common mistake here, a lot of you guys have been dividing, but to solve for X, we just multiply. So 0.55 times 0.02464 becomes 0.013552 moles. So notice that I just kept all the units there because I just put in a bunch and then I round to sig figs at the very end. That's just better practice. So here, that means my X is 0.01355 moles. And because we're at the equivalence point, we know that these two moles are going to equal to each other. The moles of the OH and the moles of the H plus are going to be the same because the solution is neutral. So here, I'm going to write that here, 0.013552 moles. So here, now I can solve for 3, right? Because I know that big M is equal to moles over liters. I just have to plug in. So if I plug in my moles, it's going to be 0.013552 moles over 0.04, bunch of zeros, liters. So our concentration is going to be 0.3388 molar. And that is our answer, 0.3388 molar. Great. Just so you know, there is a shortcut. We don't need to do this math with that giant table. It can be a lot faster if we know this formula. CV is equal to CV. Concentration of the acid times the volume of the acid is equal to the concentration of the base times the volume of the base. And just so you know, it's based on the math that we just did. So recall that we've been using the equation big M is equal to moles over liters. I'm going to do this equation twice. One for acids, which I'm going to label A's, and once more for the base. Big M is equal to moles over liters. I'm going to put a B there. And I'll show you how we get to this here equation. So let's solve for moles. That means mole of A is equal to big M A times big L A, like molarity times liters. And now mole of B is equal to molarity of the base times the liter of the base. And if you recall, the moles of A and the moles of B, the moles of the acid and the moles of the base should equal each other. That means we can make these two expressions equal to each other. So the molarity of the acid times the liters of the acid is equal to the molarity of the base times the liters of the base. So molarity is concentration and liters is a volume. Molarity is a concentration and liters is a volume. So here is our new equation. CV is equal to CV. The concentration of the acid times the volume of the acid is equal to the concentration of the base times the volume of the base. So let's redo this problem. First, I'm going to label. So these things are going to be volumes. This is the volume of my acid, right? 40 mils of HCl solution. This is the volume of the acid. And then here I have a concentration of NaOH. That must be the concentration of the base. I'm going to label this CB. And then finally, I have the volume. This is the volume of the base. I'm going to call this VB. And let's just plug in, right? Ca times Va is equal to Cb times Vb. And let's see, I got a Va, so this is point. I'm still going to do that mental math, so I'm going to write this as 0.04 liters. Put little parentheses on it so it looks nice and clear. And then I got my base, which is 0.55 molar times 0.02464 liters. Good. And then here I just have my last variable, which is Ca. Now I need to solve for Ca, so I'm going to divide both sides by 0.04, 0.04. So Ca is equal to 0.55 times 0.02464 divided by 0.04. Notice that the units cancel, so I'm going to be stuck in molarity, right? Units cancel. And if you do the math right, you will get 0.3388 molar. Great. So we have a little shortcut. That shortcut is CV is equal to CV. So we have a shortcut equation that CV is equal to CV, as in the concentration of the acid times the volume of the acid is equal to the concentration of the base times the volume of the base. So here, let's start labeling the numbers in this here question. If 20.6 mils of a 0.010 molar aqueous HCl, HCl is an acid. This makes this the concentration of the acid. This makes this the volume of the acid. Pretty easy. It is required to titrate 30 mils of aqueous solution of NaOH. 30 mils is a volume, so this must be the volume of the base. And then what is the molarity of the NaOH solution? So we want the concentration of the base. Good. So let's just plug in. Ca is 0.010 molar. All right. Times Va. I'm going to do some mental math and divide that by 1,000. That makes it 0.0206 liters is equal to Cb. That's our variable. Times, and then our volume is 30, so it's 0.030 liters. Good. Divide both sides by 0.030 liters. 0.030 liters. Liters cancel. I'm going to be stuck in molarity, which is good. That's what we want. And if you plug in the math correctly, our concentration of base is going to be 0.00 0.687 molar. Good. Much easier, much faster with the shortcut equation. Let's do one last sample problem. Again, our shortcut equation is CV is equal to CV, meaning concentration of the acid times the volume of the acid is equal to the concentration of our base times the volume of our base. Let's go through our sample problem and label all of our numbers. In the titration of a 35 ml of drain cleaner, so 35 milliliters of drain cleaner which contains NaOH, so that's a base. So this must be our volume of a base. 50.08 mils of a 0.409 molar HCl. HCl is an acid. This must be our concentration of an acid. This must be our volume of an acid. Must be added to reach the equivalence point. What is the concentration of the base in the cleaner? So at once CB is our question mark. So let's just plug in. Ca is right here, so 0.409 molar times Va is right before it. If you do some mental math and convert mils to liters, you get 0.05008 liters is equal to Cb, which is our variable, and our Vb is 0.0350 liters. Divide both sides by 0.0350 liters to get Cb by itself. So divide all of you by 0.0350 liters. Liters cancel. In fact, on this side, the numbers cancel. Liters cancel here. So I'm going to be stuck in molar. So Cb, if you did the math right, will be 0.585 molar. Great. So all I did was, number one, I wrote down the equation. Number two, I labeled all of my variables. I plugged in, and then I solved. Thank you very much for watching.